Okay, so before I get the, let me just turn this viewfinder so I can see it. Before I get the gearbox and all that other good stuff on, I want to get this headstock set and everything in place on here so I can give the bed and the tray a touch-up while I have everything off. So I've already secured the actual headstock to the ways. There are two bed clamps, one in the front and one in the back. You just have to make sure that the two mating surfaces, that there's nothing there. Now, there are shim packs on my lathe. Depending on the style that you have, you may have bronze bearings or something else, but these are just plain bearings, plain cast iron bearings that have shim packs on either side. So the shim packs are back in there. The ones on the back don't look that great. They're a little rusted out, but we should be able to get away with them. Worst case scenario, I can just remake them. It's not that big of a thing. So right now, what I want to do is get the back gear in place. Now, the back gear, if you look, reaching over here, usually has a screw covering this hole, and it's usually stamped oil or something like that. You have two choices here. You can use spindle oil in the back gear and cone pulley every time you engage the back gear, which is the way that they were originally designed. Now, if you look in, especially the cone pulley, you'll see oil grooves. They were originally designed to take oil. Later in life, Southbend recommended grease in these, and it was a specific grease. It was this stuff here that you can still get online. Okay, now the rebuild books and everything say use super lube, and that's what I used in the 9-inch lathe that I have, and I haven't had an issue with it whatsoever. But I bought this stuff just for S&Gs to see what the difference is. And looking at this, put a little bit on my finger here, the consistency of this stuff is way different. So this is like, I would put it to the consistency of hand lotion, is pretty much what it is. And super lube, you obviously know, is a lot more sticky. So this is what I'm going to use for the back gears and the cone pulley. What you do is kind of just get a skim coat in there at first, and then you can fill them up full by using a grease syringe. I got to get a syringe, but we're not going to be running this right now anyway, so I can just get all this stuff in place. So I'm going to give this inside a real quick coat, and then we'll be right back. Okay, so I got this coated, and you can kind of see the consistency there. It looks like hand lotion. Now, this goes in through these two ears, and there's a hole here, or a dimple. That dimple points down to the set screw at the bottom, and a dog point screw goes into place. So put the back gear in. That phone rings one more time. I'm throwing it across the room. Okay. Oop, I just shot grease everywhere. Alright. There it is there. I'll get the screw in place. Alright, it's going to get a flashlight, look into that hole, make sure I see that dimple in the right spot. We'll get this set screw into place, and we'll get the other set screw into place too. There's one on each side. So let me go ahead and do that. Okay, so now we're ready to get the spindle into place. The back gear's in place, and this screw that's on this side holds the position of the back gear. And then this is a split bushing over here. The other screw clamps down on that bushing, and that creates the resistance to the engagement itself. So you adjust that to your preference. I got it it feels pretty good now, and we'll see how it works when we actually put it in the back gear. Okay, so now this spindle is just in place for a second here. Now, if you had watched my disassembly video, you saw that we had one little, rub mark in here, nothing huge, and it left a little bit of raised material on this spindle. Now, this spindle is hardened. This is a very, very hard surface. It wasn't a gouge in the hardened surface. It was actually a smear of cast iron onto the hardened surface. So what I did is I have one of these little Kratex rubberized abrasive sticks. It's like a pencil eraser with grit in it, and a very, very fine grit. I don't even know what this is, smoothing and polishing on it, 066-M. I don't know what grit that is, but it's very fine. And so what I did is just went right over that surface and rubbed it off, and it, like I said, just like a pencil eraser, it got that raised material off. So we're just going to set the spindle in here for the moment. Now, the way this was originally set up, you had the cone pulley here, then you had a thrust bearing in here, then you had a fiber washer, right there, and then riding up against that fiber washer, or actually adjusting the tension and pressure of this fiber washer against its face, was this take-up nut that's screwed on here. And then you had the gear on the back that was pressed on, and there's a woodruff key in here, right here, to hold that in place. So what we're going to do is we're going to do a little bit of a modification. So we're going to take this fiber washer, we're going to get rid of it. In its place, I have a needle thrust bearing. I'm going to put that thrust bearing over the face, and that's going to allow us to have a nice rolling element here against a rolling element here, and will allow us to take up all of the slack in this pulley, or in this drive mechanism, this spindle. With the fiber washer, you can tighten it down, but you can't over tighten it, otherwise you'll start to bind up and you'll start to wear that fiber washer. So there's always going to be a little bit of rocking back and forth. With this thrust bearing, I can take all that play out of there, and it makes a hell of a lot of difference on finish, especially on facing cuts. So it's slightly bigger in width than the fiber washer, but not by much. So what I wanted to do is just make sure that's all the way back, and just very, very lightly tighten that. And it's going to be tighter than that, but I just wanted to make sure I have enough room. If I put this gear into its original position, to still have enough room to be able to adjust this take-up nut, and I got plenty of room there. So I'm going to put this all together off camera. So what I'm going to do is I'm going to take the cone pulley here. We're going to do like we did with the back gear. Rub some grease in both sides. We're going to slide that on. Then we're going to slide on the thrust bearing. Now I run these dry. I use oil for these just because it's open and it's in where chips are going to start slinging around. So, a little squirt of oil in there every once in a while is my lubrication that I use on this. And then we'll put the new thrust bearings on there, the take-up nut, and then we'll be able to press the gear back into place. I didn't do much with the gear. It's got those ding marks in there. I thought about putting it in a lathe and just facing the end off. But, it's not going to make that much of a difference. Maybe I will. Maybe I will. Okay, that looks a little bit better. Like I said, some of them are really deep, so I just took about 0.010 off of there and rounded off the edge nice with the file, and then I hit this outside edge with the file too, just to knock some burrs off. And, plenty good. Alright, so now we can get this on. Okay, we got the spindle all together. So I'm going to place the wicks in their holes. They're spring loaded. Give them a good soaking of oil. And you can kind of see the construction of them. So you have a hard felt at the top and a nice soft wick at the bottom. So picture like say a Zippo lighter. So this wicks the oil up, saturates this stiffer wick which rides against that spindle. I had to refill my oil can, but those got some oil on it. So here's the spindle. There we go. So you can see here's the ball thrust bearing, here's my needle thrust bearing. I still have plenty of room for adjustment. Okay, so now we're going to put the caps on. As I said before, I don't know how well these shims in the back are, but you know, we'll find out. Grab my Allens. Alright, now torque wise, these things don't have to be super tight, you know, just give them a little snug. About a quarter of a turn past where they were. And we're going to check our spindle clearances from there. Okay, so now that I got the some oil in there, it actually spins pretty free. But what we need to do now is tighten down this take-up nut. Now, as I said before, there used to be a fiber washer back here. When you had the fiber washer, you would tighten it down until it was tight and then back off a little bit and then tighten it down. And that would create a little bit of play in the spindle. The only thing that this is doing is keeping the spindle from flopping back and forth. That's it. When you're cutting, 90% of the time you're cutting towards the headstock. So this thrust bearing here, this ball thrust bearing, is what's taking all that pressure of the cut. The only thing that this is doing is keeping this spindle from doing that. Where the fiber wash is in place, sometimes what will happen is you'll get a lot of chatter on a facing cut, or you'll get kind of a surface finish that's kind of crappy on a facing cut. Because no matter what, you're not going to be able to take all that play out of there with the fiber washer, because you'll start to actually bind the system. So with this rolling element here, we can get rid of all that slop. And that's all that it's doing. So you don't have to worry about preload or anything like that. So the way I did it on the 9 is because you can actually tighten this so tight that you can actually start to bind the back gear. So just wiggle it back and forth, you know, tighten this down till you're in the neighborhood. Wiggle this back and forth. You hear that click? Just keep tightening it. Right there, that clicking stopped. So that's where I'm going to keep it. So now all that back and forth play is taking out of the system, and we have a rolling element here that's not going to wear out. As I said, when you're cutting, if all the pressure is back towards this way, and all that's being taken up by this ball thrust bearing. So you can see I have it in back gear right now. I can still spin, and we're not binding. We still have a little bit of play right there in the clearance in the back gears to be able to spin this perfectly fine. So let me lock this into place here. Alright, we're locked, and it's been pretty good. So these two things do need a little bit of oil, just a squirt. I don't want to put anything on there yet because I do have to paint around them and kind of tidy up the parts that I missed. But what we want to do right now is we want to check spindle clearance on our main bearings. So what we're going to do is I'm going to set up an indicator onto the nose here and then onto the back, and we're going to lift up, and I'll show you how we do that. Okay, so now we're going to test our spindle clearance. Now this is a plain bearing lathe, so it has no bronze, no expanders, no nothing. So the clearance on these you want between 1 and 2 thousandths. Now what you want to do is rig up a test indicator like so, or a dial indicator of some sort to a nice stiff part of the lathe, and you want to go kind of as close to the bearing cap as you can and stick in a piece of aluminum or brass as large as your spindle bore, come out about 1 foot or so, and you want to grab it and you want to try to lift straight up, trying to basically lift the headstock up by this bar. So we're going to push down a little bit just to make sure that we're settled. We're going to grab and we're going to lift up about 75 pounds of force or so. We're going to lift up, and right there we got 2. I'll try it again. So I'm getting 2 there. Okay, so that's within spec. I would rather see 1, but 2 is okay. What I'm going to try to do right now is just grab my Allen wrench and we'll see if we can just give these bearing caps a quick little snug. See if that changes anything. Zero that. So I'm going to grab, going to lift up, and do it again. So I'm about 1.5 there. Right now, 1.5. So I'm going to leave that as is, and we're going to go over to the other side. Maybe that indicator will show up, I'm not sure. So I'm going to do the same idea here. Grab and lift up. Alright, we're not even moving. We're not even moving there. Oh yeah. So this front, that clearance there, maybe a half. We're a little tight on the front bearing. I would like to see a little bit more movement than that there. It's just taking 1, but I would like a little bit more clearance in there. More clearance is better than too little clearance. So if I put a little shim in there, we should be good to go. Okay, so I cut myself 2 new shims out of 3 thousandths shim stock, and I peeled 1 lamination off of these shims. That should give me about where I need to be. So give me a second, I'll screw this on, we'll set up for another test. Okay, so we're going to try this again. This might be a little washed out for you guys, but you gotta trust me when I say don't hit the dial indicator. Alrighty, so I'm just going to push down and settle it out. I'm going to lift up, and right now there we go, we're at 1.5. So lift straight up, we're at about 1.5 or so. 1.5. So we're right where we need to be on that front one now. Okay, let's just see how she rolls. Definitely rolls nice and free with no signs of binding, and we're solid that way. Okay, so now I can put the two guards on, and we should be all set for this. I'm going to have to measure the belt length, and I need to order a belt. Okay, so I got both of these cavities filled with grease. For whatever reason, all my local places didn't have a regular handheld grease syringe. They all had ones that screwed onto a grease gun, which is kind of useless for me. So luckily, got the wife who's a nurse, so she was able to get me a regular syringe minus the pointy tip, and just filled this sucker up with grease a few times, made a good seal on these holes, and just injected it until I couldn't inject no more. So these two cavities are filled. I just got to get the lock or screw cap for this and put that in, and we're all set.